All right, so for today we're going to be talking about something called arithmetic series. I had mentioned that a series is a little different from a sequence in that instead of it just being a pattern of numbers, now you're starting to add the terms of that pattern together. So when it comes to what we call a finite arithmetic series, meaning we have a specific number of terms, not an infinite number of terms, there's a formula to be able to add the terms of your series together, so you don't have to sit there and add -1 plus +1 plus 3 plus 5 plus 7, even though that one obviously wouldn't be that difficult. What if you had to add 150 terms? I'm sure you're not going to want to sit there and add them one by one. So I'd like to go back to the do now that you had worked on the previous lesson for sigma notation. If I want to add up the numbers from 1 to 100, because of the fact that the sequence 1, 2, 3, 4, all the way up to 100 is an arithmetic pattern, you remember it created these pairs of numbers that always added up to the same thing. 1 and 100. 2 and 99, 3 and 98, and always they added up to be 101. There were 50 pairs of numbers. Each pair added up to 101, so when I multiply 101 times 50, that's how I got the sum of my 100 numbers without having to sit there and do 1 plus 2 plus 3, etc. Okay, so again, as long as you're dealing with an arithmetic pattern, you can add the terms of that series together by using this formula that we had come up with during that do now. So remember, we're pairing our numbers together. Let's say n is the number of terms in a sequence. If you take the number of terms in your sequence and you divide it by 2, that's going to give you the number of pairs you have when you add all those together. And then the constant sum you keep getting over and over and over comes from adding the first term plus the last term. Okay, so that's the formula you're going to use to add up the terms of an arithmetic series. And once again, it's important that the pattern of numbers that you're working with has an arithmetic pattern, adding or subtracting by a common number over and over. So if you take a look at question number 1, -1, 1, 3, 5, 7, you can see that each time to get from term to term, you're adding by 2. That's what makes it arithmetic. Okay, so if you take a look in this particular case, how many terms do we have? 1, 2, 3, 4, 5, 6. Okay, so 6 terms. What's the first term that we have? -1. What's the last term that we have? 9. So when I use this formula, I'm going to take the 6 terms I have, divide it by 2, and multiply that by the sum of the first term and the last term. Okay, and when I actually complete that, that together comes out to be 32. Now, obviously, again, this was a small number of terms, so you could easily go in your calculator and add up -1 plus 1 plus 3 plus 5, etc., and you'll see that you end up getting the same answer. Okay, so let's try a couple more examples with some different ways the information is presented. So in this question number 2, it says, given the series and the number of terms in the series, find the sum. So remember what we need. We need to know how many terms do we have. Well, they thankfully give us that it's 16 in this case. We need the first term, which in this case is 20. This one's a little more complicated than the previous one because I need the 16th term to be able to get my last term in this situation. So I'm going to have to come up with an arithmetic rule to figure out the 16th term so I don't have to sit there and add up until I get to the 16th one. So if you remember back from our previous lessons, when you want to create a rule for an arithmetic sequence, the rule was a sub n equals a1 plus n minus 1 times your common difference. Okay, that was our arithmetic sequence rule. So if we want the 16th term, okay, we're going to take our very first term, which is 20. You're going to add that by n minus 1. Remember, 16 is your n, so 16 minus 1 times your common difference. The way I go from 20 to 27 is that I'm adding by 7, so my common difference is 7. And when I do that, I find out 125 is my 16th term. Okay, so now I have everything I need. My n, how many terms I have, my first term, my last term, and then I'm going to go back and plug them into this formula that we have up here. N over 2 times a1 plus an. So I have 16 terms divided by 2, multiplied by my first term plus my last term, and when I complete that, that comes out to be 1160. Sometimes you'll see this, by the way, written as S sub 16, which means the sum of your first 16 terms came out to be 1160. Okay? So I would encourage you to go back and try this example on the worksheet just as another version of, working through that problem and seeing, okay, what do I have to do? I have to find the number of terms. I have the first term. I'll have to use what I know about arithmetic sequences to find the last term, but obviously with a different set of numbers. Okay, so for the next problem, we're once again finding the sum of a series. I like in this question because it really highlights the difference between a sequence and a series. So you'll notice that a sequence, again, is just a pattern of numbers. Once you start adding that pattern of numbers together, that's when it turns into a series. And so you can see in this case, I have the first term, so I have that the first term is 5. I have the last term is 93, but what I'm missing this time is how many terms I actually have. So let's think about how we know about making rules for arithmetic sequences, and let's use that to work backwards to find out what is the value of n. How many terms do we have? Okay, so once again, arithmetic means I'm adding by a common difference. You can see here the common difference is 4. So if I was going to make an nth term rule for this problem, my nth term comes from the first term plus n minus 1 times the common difference. Okay, so what we're going to do is we're going to think of an as our last term being 93. Our first term is 5. N is what I'm going to be solving for, and I know that my common difference is 4. So now I pretty much just have to work in through this equation to find that value of n. So if I subtract 5 from both sides, that gives me 88 is equal to n minus 1 times 4. I think you saw me do this in one of the earlier problems, but instead of distributing, I'm going to go right to dividing by 4, and that gives me 22 for the value of n minus 1. So when I add 1 to both sides, that tells me that n equals 23. Okay, so now I have everything I need to be able to plug into my arithmetic series formula. The arithmetic series formula, again, is n over 2 times a1 plus an. Okay, so I have 23 numbers divided by 2, multiplied by the sum of the first term and the last term. And when I do that all together, this is an example of saying something like s sub 23, the sum of the first 23 terms, and this value comes out to be 1127. Okay, let's take a look at another example. So if I go down to sigma notation, okay, so in sigma notation, that's a shorthand for a series, so a shorthand for a bunch of terms that are being added together. Remember that if you wanted to find the actual terms of that series, you'd start plugging in. Here you'd plug in n equals 1, and then n equals 2, and then n equals 3, and then you'd get a bunch of numbers. So if I plugged in n equals 1, I would have 8. If I plugged in n equals 2, I'd have 11, and so on and so forth. That's the series that I'm actually finding the sum of this time. Okay, so how am I going to actually use this to do that arithmetic series sum formula? What do I need again? I need to know how many terms do I have. I need what is the value of my first term and what is the value of my last term. Okay, so how many terms you're going to have, and this is a little weird, you're probably going to go, oh, shouldn't it just be the top number? Well, if the bottom didn't start at 1 like it did in this problem, like if you look at the question number 7, it doesn't start at 1, it's not as simple as just taking the value on the top of the sigma. What you're actually going to need to do to figure out the number of terms you have is take the top number minus the bottom number plus 1. So that's why in this case it does actually work out to being 33 terms. But if you look at number 7, my top number minus my bottom number plus 1 works out to be 5. That's how many terms. And hopefully that makes sense because look what you're doing. You're plugging in 5, 6, 7, 8, 9. That is a total of 5 terms altogether. Okay, so back to the example we were working on. We figured out we have 33 terms. Our first term should come from plugging in whatever the value is on the bottom of sigma. Thankfully, that is actually a1. And as I had done before, 3 times 1 plus 5 comes out to be 8, so my first term is 8. Be careful, because if I wasn't starting at 1, my first term, and you can't see this, but I'm using hand quotations, comes from whatever the value I get when I plug in the number on the bottom of the sigma. Okay, so then my last term, my a sub n, in this case is going to be a sub 33, the value you get when you plug in the top number on the sigma. So I would have 3 times 33 plus 5, and that works out to be a value of 144. Sorry, 104, not 144, sorry. Okay, so now I can take all this information and I can plug it into that arithmetic series formula. N over 2 times A1 plus A sub n. Okay, so I have 33 terms divided by 2 times the sum of my first and my last terms. And so in this case, this comes out to be the sum of my first 33 terms. And in this case, it's 1848. Okay, so just to illustrate what I was speaking of with regard to like if you have different numbers on the top and the bottom, take a look at number 7. Once again, what do you need? You need your first term, you need your last term, and you need the number of terms. The number of terms, again, comes from the top number minus the bottom number plus 1. That tells you have 5 terms here. This time, the first term is actually not going to be A1. It's actually going to be A sub 5. The first value you get when you plug in the first number of that sigma. So that would be 3 times 5 minus 4, and 3 times 5 minus 4 comes out to be 11. Your last term, in this case, is going to be A sub 9, the number you get when you plug in what's on top of the sigma. So 3 times 9 minus 4 comes out to be 23. Okay, so once again, you're using that idea of your n value divided by 2 times the sum of the first and the last values. In this case, technically, this would be something like S sub 5 because you're only adding 5 terms together, but honestly, nobody cares about that notation. You could just literally write that the sum comes out to be 85, and you don't have to do anything with like showing that notation in the front. Okay, one last example, just to kind of, give you an example of kind of tying everything together. This says write the series in sigma notation and find its sum. Okay, so this is a good recap of what we had worked on last week when we were dealing with arithmetic sequences. So if you take the pattern 2, 7, 12, etc., let's write a rule for that sequence. So as I go from 2 to 7, I'm adding by 5, and 7 to 12, I'm adding by 5, so I have a common difference of 5. If you remember again, for an arithmetic sequence, it's A sub n equals A1 plus n minus 1 times d. So A sub n is equal to my first term, which is 2, plus n minus 1 times 5. So if I wanted to now turn this into sigma notation, sigma is going to always start with n equals 1. I'm going to have to figure out what n value I plugged in to get 122 to put a value on the top. And then the rule for A sub n without the actual A sub n part is what goes here inside my sigma. So I'd end up with 2 plus n minus 1 times 5. Okay. So I'm going to need to use my arithmetic sequence formula we came up with to find the value of n. Okay, that's what I'm missing right now that I need for not only the top of my sigma, but also to know how many terms I have that I'm adding together for my series sum rule. So I'm going to plug in the fact that I know that the nth term was 122, and I'm going to work backwards to solve for n. When I minus 2 from both sides, I get 120 is equal to n minus 1 times 5. Let me just scoot this over a little bit so I can get that out of the way. When I start solving this, I have 120 is equal to n minus 1 times 5. Divide both sides by 5, and I get 24 is equal to n minus 1. So when you add 1 to both sides, you find out that 25 is the value of n. You have 25 terms that you are adding together in this series, and to get the last term, you're plugging in 25. So now to finish and actually figure out what the sum comes out to be, you're taking the fact that you have 25 terms, which, by the way, is still the same thing as if I took top number minus bottom plus 1. You don't have to actually do that this time, though. So 25 terms divided by 2 times the sum of the first term plus the last term, which comes right from the information they provided you in the question. And when you figure out that sum, it comes out to be 1,550. Again, if you want to have proper notation, this is